We will follow the discussions with learning about the trade-offs and challenges in meeting user expectations while designing and deploying web systems. To do this, we will first discuss major requirements of a system: availability, consistency, latency, resiliency, scalability, and security. Users expect a web system of their desired service to work whenever they need it. They do not want to have to wait to shop when an e-commerce website is down or not get a response when they want to log into their webmail or social media. This, for the web system, means high availability. Availability for a web system means that the web system should run with no significant downtime, so that every client request sent to the service can succeed and receive a response. Service availability depends on the running of the application that provides the service, as well as availability of its stored data. Now, consistency. Consistency describes the behavior compliance of the system in meeting a set of rules in regards to data in memory or database stored data. Do you remember the consistency from discussions and the asset properties of relational databases? It described the requirement that database should go from one valid state to another valid state. Consistency in the context of web systems architecture, although related as we will discuss, is different in that it involves consistency of data in distributed systems. That is, in the simplest words, keeping the multiple copies of the data consistent if possible. The user requirement involved is fast access to data, no matter how in the background service the access is made possible. We will discuss this within data-centric and client-centric modeling of consistency and review algorithms, trade-offs, and constraints in meeting this requirement. Latency, the time between a user or client application's request and a provider service's response, is an important performance metric for web systems. This could be breakdown to system latency, network latency, and application latency. Shared resources, background services, queuing, energy management, and garbage collection can contribute to system latency. Network latency, which could be measured with ping or traceroute, is caused by the availability of network resources, affected more commonly by link bandwidth or congestion within the network. Web application-specific latency is affected by the specific application and could be measured by end-user metrics. For example, time to first byte, which is the time that it takes for a user's browser to receive the first byte of page, or time to interactive, which is the time to availability of interactive functionality of page elements. Resiliency is often mistaken with durability or availability. Although it affects both of these characteristics, it is completely different. The ability of the system to recover from failures and continue to function with minimal downtime and data loss before full recovery is called resiliency. It is usually measured by MTTR, or mean time to recovery, which is the average time it takes to restore a component after a failure, or MTBF, or mean time between failures, which is how long a component can reasonably expect to last between outages. And it is specified by metrics like RPO, or recovery point objective, which is the maximum acceptable time an application can be unavailable after an incident. Scalability is the ability of the system to handle increased load. Scalability in web systems has a close coupling with the cloud model used for the system. The challenges addressed by the cloud provider in the modern cloud involves load monitoring and prediction, as well as resource pooling, allocation, and instance initiation. In the meantime, the web system architect should make sure to know the cloud operations, to know how scalable they could be, and ensure design for concurrency and partitioning to support scalable operations.